Welcome to Master Simple Physics. Today's topics will be on conversions between speed, velocity, and acceleration versus time graphs with a simple maths. I believe most of you should know, if you are good in mathematics, you should have less problem in physics. But here, I make assumptions that most of you do not know what is called differentiation methods. Although I put the terms here, I just hope that you take it as a division method. As you're understanding, velocity is defined as the change of displacement versus the change of time. And if we write in terms of differentiation methods, we'll change it to ds over dt. Whereas for the acceleration, a is equal to the change of velocity versus the change of time. Similarly, we rewrite it in the differentiation method. We write a equal to dv divided by dt. Okay, let us look at the first graph on the left. That is a displacement versus time graph, which is a straight line passing through 0 with the positive gradient. Since it is a straight line, I can choose the time frames. From here, I read the time period is from 0 to 4 and the displacement is equal to 12. So I'm using 12 minus 0 divided by 4 minus 0, hence equal to 3. For the velocity versus time graph, how do we obtain acceleration versus time graph? As we know, A is equal to delta v divided delta t. Since velocity is constant from the time equal to 0 to 4 seconds, therefore the acceleration should be equal to 3 minus 3 divided by the time frame. Let's say we choose 1 second, so it's 1 minus 0, it will be equal to 0. So that is why you see the line is sitting on the x-axis. For a linear graph, differentiation method actually is just a simple division method. Now we introduce another method called integration methods. Actually, this is the summation method. It's just looking for the total area on the graph. First example, we are going to look into how to change the velocity time graph to displacement time graph. As we know, velocity is equal to the change of displacement over the change of time, and we rewrite as just now we mentioned, v equal to ds over dt. We multiply the denomination to v, therefore we get the answer is ds equal to v times dt. Both sides we do integrations, that means we look for the total sums. So equal to displacement will be equal to the total displacement for the period from 0 to 3 seconds or minutes, depends how you draw the graph. Therefore, writing the equation is v times dt. So in this, then after that we express the v expression into the equation. Look at the v versus t graph. Can see that the velocity is equal to 4 throughout from time equal to 0 to time equal to 3. Displacement is equal to area on the graph. So now we gradually calculate 0 to 1 second. The total area is equal to 4, 0 to 2 is equal to 8, and 0 to 3 seconds is equal to 12 meters. If you know how to use integration method, that will be very easy for you. Okay, now assume you do not know how to use these integration methods, so we gradually put the totals values into the graph. From 0 to 1 is 4, we plotted on the right hand graph. 0 to 2, so we have a plot at 2 equal to 8. Then 0 to 3, we plot 3 equal to 12. Then after that, we join all the points to get the answer. Second example is to convert acceleration time graph to velocity time graph. As we know, acceleration is equal to the change of velocity divided by the change of time. Similarly, as what we say, we rewrite a equal to dv over dt as a differentiation. Then after that, we use the denominator dt times a. We get dv equal to a times dt. Both sides we do integration. Assume we talk about the time is from 0 to 3. Therefore, it will give you the total of velocity over a period. Look at A versus t graph. We have a straight line passing through 0 with the positive gradient, where A is equal to 10 divided by 3 times t. To convert accelerations to velocity time graph, we can gradually calculate the area under the straight line from 0 to 1 second, which can be representing of half time. The height times the base is 3 times 1 equal to 1.5. The time from 0 to 2 seconds is half time, 6.5 times the time is the base equal to 2.5. For time from 0 to 3 seconds, we can calculate the area as half times 10 times 3. 10 times 3 equal to 15 meters per second. If you do not want to do the calculation, you can count the box under the graph and find out the areas. On the V versus time graph, we can use 0 to 1, you say 1 second is equal to 1.5 plot a point, and 2 seconds we can get 6.5 and find a point. Then 3 seconds is 15 meters per second and get one more point. Then we join 3 points to get the graph. Should we take a challenge to convert a more complicated VT graph into AT graph? Look at this velocity versus time graph. At the beginning, there is a positive gradient straight line. Then there is a flat straight line from time 1 second to 3 seconds. Subsequently, we have a negative gradient straight line going back to 0. The table is to help you how to get the accelerations from time 0 to 1 second. The gradient is equal to 10 minus 0 divided by 1 equal to 10 meter per square second. We can draw the red line onto the AT graph. So for the time 1 second to 3 seconds, because the velocity is equal to 10 meter per second, which there is no change in the gradient is equal to 0. Therefore, we from 1 second to 3 seconds on the AT graph, we draw a straight line at the x-axis. Then from 3 to 3.5 is the negative gradient. Is calculated the gradient equal to 0 minus 10 equal to 0.5, 10 equal to minus 5. Therefore, we can get a equal to minus 5 is shown on to the graph on the right. For VT graph to ST graph, we are using integration methods. It means that we have to look at the VT graph and calculate the total area under graph from period to period. Use the same velocity versus time graph. And now we use the table to slowly calculate the area under graph from the period from 0 to 0.5. We get 1.5 areas, 0.1 equal to 5, 0 to 1.5 seconds, we get 10, then 0 to 2, we have 15, 0 to 2.5, the total areas is equal to 20, 0 to 3 seconds, the total areas is equal to 25, and 0 to 3.5, we get total is 25.5. To calculate the total area under graph, you use a very simple mathematics. Hopefully you can read it yourself. From the table, we will be able to get the times and S value. We plot individual points and subsequently we link all the points together to get the graph. Here I would like to highlight the VT to ST curve. For VT curve is the positive gradient straight line. You will be able to get a gradually curving outwards from 0 to 1 second. When the velocity is a constant, the st curve is a positive straight line gradient from 1 to 3 seconds. For velocity is with the negative gradient, you can see the curve is gradually turning downwards. So far, we have learned the basic concept, how to do the conversion between st, vt, and at graphs. The attached diagram is meant for your revisions. Hopefully, you will be able to understand how it works. Thank you for your attention. Hopefully, this video will be able to help you to understand the concept well. Thank you.